I always want to make soap outdoors, and the weather is amazing today. So I'd set myself a big challenge. Make soap without electricity. Let me show you how it went.
I'm in the forest today and I'm gonna make soap that is gonna smell exactly like that. Rosemary, patchouli and an essential oil that is gonna try to accelerate our trace. But why is today's episode so special? As you know, when we make cold process soap, we need electricity. We need electricity to melt our solid butters like coconut oil, shea butter or beef tallow over a double boiler. And we also need electricity to stick blend. So usually we have a stick blender in order to mix our oils and lye solution together. But today we don't have any of this. So what do we need to do instead? First of all, we need to melt shea butter and coconut oil. And in order to do this, we're gonna use the heat released from the lye solution. So we're gonna use the lye solution as our double boiler. This is the first time I'm doing this. This is the first time I'm making soap outdoors and I'm very excited for it. After we do this, then we're gonna mix our oils and lye solution together in order to make soap, and we're gonna hand whisk. Yes, you heard me right. It's not ideal, but it's the only thing we have right now and we're gonna make it happen. So soap is made through the traditional saponification reaction between oils and lye. How does that work in principle? You have your oils like olive oil, coconut oil, shea butter, castor oil, and then you have your lye solution, otherwise known as sodium hydroxide. But what is lye? Lye is a basic substance, basically a substance of high pH, that what it does is that it converts your oils into soap. Oils and butters contain fatty acids. Olive oil contains oleic acid. Oleic acid, once it reacts with lye or sodium hydroxide, it converts to sodium oleate, which is a substance that gives conditioning properties to your lather and creates a very gentle soap. Soaps with a high concentration of olive oil are perfect for sensitive and dry skin. The most popular soaps in the world, Aleppo soap, Marseille soap, Castille soap, they all have one thing in common, and that is that they are made with a high concentration of olive oil. Coconut oil. Coconut oil contains lauric acid, and when it reacts with sodium hydroxide, it creates sodium laurate. And sodium laurate is what adds bubbles to your soap. So when we say coconut oil is what adds cleanliness and bubbles to your soap, we don't mean actual coconut oil. If you take coconut oil and rub it on your skin, it won't start bubbling. It's once it converts to soap, once it reacts with sodium hydroxide and converts to sodium laurate, that it actually adds bubbles and cleansing power. Then we have shea butter. Once it reacts with sodium hydroxide, it creates this very luxurious and creamy lather because it contains stearic acid, and stearic acid reacts with lye to produce sodium stearate. So let's first go ahead and measure our coconut oil and shea butter, which is our solid oils, our solid butters, in a stainless steel bowl, and then we're gonna melt them down. So we're gonna go ahead with 95 grams of coconut oil and 125 grams of shea butter. And by the way, if you want a free soap making recipe that contains shea butter, coconut oil, olive oil and castor oil, and it also includes a long-lasting essential oil blend with patchouli essential oil, then comment soap and I will send to you as soon as I see your comment. And now we are gonna go ahead and prepare our lye solution. So when you prepare lye solution, you have to be careful. Here's the thing, lye, sodium hydroxide, is caustic, meaning that it can burn your skin. So always make sure you wear protective gear, gloves, goggles, and always make sure you are in a well-ventilated area. Don't stand right above the bowl with the lye solution because it creates fumes and you shouldn't smell those fumes. So always make sure you're in a well-ventilated area and don't stand right above the bowl. And the other very important rule is to always add the lye in water and never the other way around. If you add it the other way around, you will create a highly exothermic solution that will create a lot of heat, even more heat when you add the lye in water, and it can actually be very dangerous because it can actually start splashing everywhere. So always add lye in the water. So let's wear our gloves, and the first thing we are gonna do right now is that we are gonna add our distilled water. Can you make soap with tap water? Absolutely, but it's not ideal because tap water contains impurities like salts and heavy metals that might interfere with your saponification reaction. So if you want consistency over your batches, always use distilled water. So I'm gonna go ahead and add 132 grams of distilled water. And now we are gonna add 71 grams of sodium hydroxide in the distilled water, and we're gonna use the heat of the lye solution to melt our solid butters. So let's go ahead and do that. We're gonna mix our lye solution, and right now it starts producing fumes. You can already see it, so I'm gonna mix it very, very well. And now I'm gonna place on top my bowl. I really hope this works. Maybe I should go ahead and take it to the sun. I should take it to the sun where it's hotter to make sure that to make sure it's completely melted. Actually, it's not a good idea to take it to the sun because I will have to place it on the grass, and the grass is actually cold, so that will cool down my lye solution. So I want to leave it here and hope for the best. I'm gonna break the butter into small pieces to basically increase the surface area. As you can see here, it starts melting, and I'm trying to basically break it into small pieces to get as much of this heat as possible. So what we are gonna do instead is that we are going to add olive oil. So I'm gonna add olive oil in the hope that the olive oil will help melt down the other solid butters as well. So I'm gonna add 250 grams of olive oil, and then I'm gonna add 30 grams of castor oil. Castor oil is high in ricinoleic acid, and it will add a lot of thickness and richness to our lather. And now I'm gonna put it on top of the lye solution again, and I'm going to try to mix it. We are getting to something. So now I'm going to whisk. And the reason I'm going to whisk is that I hope that the whisker will make it better. Probably never gonna be as melted as when you have a double boiler, but at least we're gonna try to get as close as possible to that. So while I'm mixing, let's talk about essential oil blend. So we want something herbal, we want something foresty, and we're also gonna add a citrusy top note to spice things up. In soap, you can have essential oils or you can have fragrance oils, or a mix of two. Essential oils are natural, fragrance oils are synthetic. Now, essential oils are of course natural, but they tend to evaporate really, really fast. They tend to degrade because we are in an environment of high pH, high alkalinity, and high temperature that tends to degrade substances. So you should always make sure to have an essential oil blend that contains a base note. What is a base note? A base note is something like patchouli essential oil. Patchouli essential oil is a natural oil that's of high molecular weight. It's very heavy, and the fact that it's very heavy means that it evaporates very, very slowly. So it's very, very long lasting. It can last up to a year in soap. So when you pair other essential oils with patchouli, you make your whole essential oil blend more long lasting. And this is exactly what we're gonna do today. So for our essential oil blend solution, we are gonna use a total of 20 grams of essential oil. So first, we want 30% of that, which is 6 grams, to be patchouli essential oil. That will hold and make sure everything is long lasting. Then I'm gonna go ahead and add 3 grams of cedarwood essential oil, which is also an amazing base note, but it's also very dry. It's very dry, and the fact that it's very dry means that it makes a lot of other substances linger in the air. Now I'm gonna go ahead to our rosemary, which will make our whole essential oil blend more herbal. And I'm gonna go ahead and add 5 grams of that. And then I'm gonna finish with 5 grams of meichang or Lychea cubeba. It's the same thing, because Lychea cubeba is a very stable top note. Usually top notes tend to evaporate fast, but Lychea cubeba is amazing because it's a very stable citrusy top note, and it will really give definition and a spark to our essential oil blend. Our oils solution looks like that. It's not perfect, but we are outdoors and that's the best we can do. Normally, we want to mix our oils and lye solution at around 30 degrees Celsius in low similar temperature. I know now they're probably much lower than that. That might have a negative effect in our emulsification. But we will make sure we mix as hard as possible. So let's go ahead and add our lye solution into our melted oils and butters. So basically now emulsification starts. Our oils and lye solution, they start becoming one already. And now comes the time of mixing, and we have to mix a lot here. This is by far the most beautiful, interesting, but also the hardest soap making I've ever done. Okay, that took some time. We have reached a nice emulsification. I'm gonna go ahead now and add our essential oil blend. I'm not really concerned about trace acceleration here. We have a very, very low temperature. So what I want to do now is that I would like to add a pigment. So I'm gonna use some green oxide, and in order to do that, I will first have to dissolve it in some water in order for it to not create any clumps. Now green oxide is going to provide with this amazing forest green color, and for that I'm adding half a teaspoon. So in general you can add 1 teaspoon of oxides per pound of oils or per half a kilo of oils. I'm going to dissolve it in some water first, and then I'm gonna add it into my soap butter. So what I wanna do first is that I'm gonna split my butter into 2. I am going to add the green oxide in half of it. And I'm gonna mix to create this beautiful color. We are ready to pour into the mold. So let's go ahead and do that. Let's wait 24 hours and let's see how it turns out. I'm excited for this. I'm also a bit worried. Usually when you make soap, you want to make sure you're at about 30 degrees Celsius when you mix your oils and lye solution together. And you want to make sure you reach a good emulsification. I believe we did, but we are not completely sure if we did until we see the result tomorrow. If tomorrow we see a very solid, hard soap that it's very easy to remove from the mold, then we have a good indication that our soap making was successful. And then the ultimate test, of course, will be to do a pH test to test the pH after 4 weeks and to also try to see if it's actually working properly fine. These are not ideal conditions to make soap. This is experimental, so of course I'm not going to sell that soap. This is just an experiment that I always want to do, to make soap outdoors without any electricity and see how it turns out. So I just came back home, and what I did actually to make sure that our soap is going to be nice, long-lasting and hard and easy to get removed from the mold is that I placed it in the oven at the lowest possible temperature. I basically heated the oven at 30 degrees Celsius, which is the lowest temperature that my oven can go to, and then I turned it off and left it inside with the light on, and I'm gonna leave it inside for approximately 3 to 4 hours. This is the so-called cold process oven process method, and it's used in order to basically accelerate saponification, accelerate gel phase, make colors pop, and it also leads to a very, very long-lasting soap. The cold process oven process method is not suitable for all types of soaps. So it's not suitable for soaps that contain milks or juices that tend to overheat, or for soaps that contain colorants that can go brown. For example, if you make a soap with watermelon juice and you put it in the oven, then the watermelon juice will go completely brown because the temperature really degrades the color. So you have to be working with stable colorants like micas, oxides, ultramarines, and make sure you don't have anything that overheats our soap. So let's see how it looks like tomorrow, and let's see if that method worked. 24 hours have gone by. Let's see how our soap looks like. So half was the forest soap and half was the banana soap. So I'm gonna try to remove both of them. It's actually quite hard. I was expecting much worse. I'm gonna let it like that. I'm gonna leave it as a cube. So let's go ahead and stamp it. I'll stamp it from this side so it looks like that. So our soap is nice and hard, but honestly guys, I wouldn't recommend this method for cold process soap making. So this method is not ideal. So even though our soap is hard, we still need to check it after 6 weeks to see if it's completely good in the sour and if it passes the pH test. So my takeaway from this experiment is that it's totally possible to make soap without electricity, but it's not ideal conditions. And if you want to join a private community of amazing soap makers alongside with video courses, ebooks, soap making tools, so make sure you click the link in bio and join the formulators community. So here's the final result. Guys, thank you so much for following me in this adventure of making soap outdoors in the forest without electricity, with a whisker and with using the heat released from the lye solution. It was, I would say, a very exciting day, a very beautiful day, and perhaps the most challenging soap I've ever made. So I hope you really enjoyed this video, and I'll see you guys next time.